All right. So to do 2D kinematics, two-dimensional kinematics, we really have to start to pay attention to the vector nature of velocity and acceleration. And so we're going to step back here and make sure that we understand how to add and subtract vectors. This short video will be just about how to do that graphically. What does it even mean to add two vectors together? So if we look at this image here on the right of our little race car going around its track, um, we can ask, like anything else, how far has the car moved? What is its displacement from its original position, R naught, to its final position, R or RF? The change in displacement is calculated the same way as we talked about it in kinematics, that is, as a subtraction. Okay, so if this were one-dimensional, right, and say we were at x equals 2 initially and moved to x equals 8, then we would have 8 minus 2, and the change in position and displacement would be about 6, right? Say that was in meters. But these are vectors, right? And when we get into 2D, adding and subtracting those vectors becomes a little bit more complicated. And that's what we're going to do today, is get an introduction to how to add and subtract vectors, which we'll be using a lot over the next couple of classes and later in the class as well. So we're going to start by thinking about what it means to add and subtract vectors graphically. That is, when we just draw some pictures. So if we are going to add vectors A and B here, A is the red one, B is the blue one, we write it like this with our vector symbols to let us know that we're adding vectors. And the way that we do that is we put them head to tail. Okay, so we take B and put the tail of B right at the head of A, and it gives us a summed vector here, R. Now, just like with regular addition, we could reverse this. If we said B plus A, well, then B would go out here, right? And then A would go here. And we'd end up in the same place. So we can say A plus B or B plus A, it doesn't matter. We're going to end up with this summed vector R. So that's what it means to add them when we just think about what does that even mean to add some arrows to each other, put them head to tail. Now, if we want to subtract them, we have to think about this differently. So here we have A minus B equals D. And the trick here is that we put the tails of the two vectors in the same place, and then the vector that goes from the head of B, that is the vector that's being subtracted, to the head of the vector A, that is the vector that we're subtracting from. Okay, so we get this vector D here as the difference between those two heads. Now this one we can't reverse, right? If I said B minus A and B would stay the same, but our vector would be the exact opposite. It would head in the opposite direction. But notice something here. If you get stuck on this, you can always go back to addition, which I think is a little easier to get your head around. So if we add the B vector to both sides of this, we would have A equals D plus B, right? And there we would get B plus D equals A. Okay, so we can move vectors to either side of the equation by adding and subtracting, just as we would with regular algebra. Okay, so that is subtraction.